Afternoon. Welcome to a close-up look at ceiling radiation dampers. I'm Scott Arnold, Senior Manager of Publications and Standards for Air Movement and Control Association International. On behalf of our more than 400 members worldwide, I want to thank you for joining us. We realize there's a lot to see and do at the AHR Expo. We respect and value your time and hope you find this educational session worth your while. The information contained in this session is provided by AMCA as an educational service. In making this educational activity available, AMCA is not endorsing, sponsoring, or recommending a particular company, product, or application. Lastly, this session is protected by U.S. and international copyright laws. Reproduction, distribution, display, and use of the material without written permission from AMCA International is prohibited. And with all that out of the way, let's meet our presenter. With a unique background in the manufacture, marketing, application, and sale of a variety of HVAC products, Michael Balzomi is Product Manager, Commercial Dampers for Greenheck. He has been involved in the development of building standards, authored numerous white papers and trade publication articles, and participated on a number of technical committees. He's a member of ASHRAE and the National Fire Protection Association, and chair of the AMCA International Fire and Smoke Damper Subcommittee and the Technical Committee for AMCA Publication 503, which is the association's application manual for fire, smoke, combination fire smoke, and ceiling radiation dampers. Michael?
So we're going to jump right into what a ceiling radiation damper is, but actually before we do that, I need to know who I'm talking to. All right, ceiling radiation dampers are kind of a unique damper product in the life safety world. They're often misunderstood. So if you are a design engineer, please raise your hand. Do I have any installers? Code officials? Any architects? Okay. What is a ceiling radiation damper? Here's your definition. That's out of 90A. We only care about one thing for a ceiling radiation damper. It limits radiant heat transfer above the floor ceiling or roof ceiling assembly. And they go by many different names, right? This industry, we love our regional dialect and our names. A CRD is the short term for ceiling radiation damper. I'm going to refer to the rest of the presentation as a CRD to prevent me from having to say ceiling radiation damper 6,000 times. You might hear it called a radiation damper, just the ceiling damper. You might hear it called a ceiling fire damper, wood truss damper, wood joist, or for my Canadians, fire stop flaps. You'll notice I put an X through ceiling fire damper. That was an older terminology. It's very misleading and confusing. Ceiling radiation dampers are not fire dampers. Fire dampers have different test standards, different applications, different installations. Just earlier in the industry, we kind of called them ceiling fire dampers as a slang. Some model numbers may reflect that acronym CFD, but for all intents and purposes, we're trying to get rid of that out of the industry. So we get that fire damper association away from radiation dampers. So where are CRDs installed? Very simply, they're in fire-rated ceilings. We find them behind diffusers, grills, registers, in lay-in drop ceilings that are rated. We find them behind membrane penetrations, through the rated space in a closet air handler, or through any other ducted penetrations above the space. Just a quick note, CRDs are used in a membrane penetration. We'll go through some of the building code in a little bit. They're not and should never be used to create a through penetration. We don't ever want to completely penetrate through that rated assembly from one side to the other, bringing ductwork. That would be where you would need perhaps a fire-rated shaft, okay? So we'll go through some more. Okay, where CRD is not found. You would think it's inherent in the name ceiling radiation damper. Ceiling dampers do not go in sidewalls. Ceiling dampers do not go in floors. Now I put a little asterisk, I should have put a little asterisk about floors. Talk to your code officials, depending on interpretation. There are ceiling dampers, they're tested in floor ceiling assemblies. And there are some areas of the country where radiation dampers are approved in the floor. The intended application for a ceiling radiation damper is in a ceiling membrane. It's always up to the authority having jurisdiction to interpret the code, to interpret the ratings in conformance with what they believe is correct. So consult your local code or authority having jurisdiction when it comes to floors, but always dryer exhaust penetrations. We don't want to put a ceiling radiation damper. And then the last one that does have the asterisk as well, range hood penetrations. That is a challenging installation depending on the type of range hood that is being used, but you are penetrating the membrane. That requires protection per the building code. So how does it protect an assembly? Here's the little diagram. Essentially, we have our fire-rated membrane, a continuous barrier. Could be a lay-in T-bar drop ceiling, could be a gypsum board ceiling. As soon as I penetrate that ceiling, I've interrupted the continuity of that barrier. So in a drop ceiling, maybe it's a 2x2 diffuser opening, and I put a diffuser, the back pan, the metal back pan, that's exposing radiant heat. The duct opening, the duct collar of that inlet, it's a place for radiant heat to escape past the rated barrier. So we put a ceiling damper on that. We put a thermal blanket on any exposed sheet metal of that back pan. And that maintains the continuity of that barrier, and it protects the structural integrity of the structure above it. So it's steel truss, wood truss, concrete floor, whatever it may be, it protects that. And we know falling through floors and roofs is one of the leading killers of firefighters. We need people to egress out of burning buildings easily and safely, so we want to make sure those buildings don't collapse. And where are they required? When are CRDs required? So this is where we go to Chapter 7 of the International Building Code. Chapter 7 is ducts and air transfer, fire and smoke protection features, and then we go to the ducts and air transfer openings. And I'm not going to read everything here, but some things to point out. We first see 71731. That is the test standard requirements of dampers per the building code. It'll give you fire, smoke, combination fire, smoke. Number 4, and I will read this, ceiling radiation dampers shall comply with the requirements of. It's a very important distinction. Shall comply with the requirements of. Doesn't say must be UL tested and listed. It says shall comply with the requirements of UL 555C. And this word right here is where a lot of challenge comes from. The word or. Or shall be tested as part of a fire resistance rated floor ceiling or roof ceiling assembly in accordance with ASTM E119 or UL 263. This isn't a choose your adventure, designers. This isn't, I'm going to pick either a UL 55C or just because. The barrier in which we are penetrating makes all the difference. You must know the assembly in which we are penetrating to determine the appropriately tested and rated damper. All right, so that's why I ask if there's any architects here. Because my engineers, where do you get your barrier ratings from? The architect. You put a note on your drawing. You put a detail, CRD required. You're going to get a phone call. What is the design number of the floor ceiling or roof ceiling assembly being penetrated? We cannot determine the damper that is appropriate for use until we know what that is. And I make a big deal about the shall comply with the requirements of, because UL is not the only agency that lists, tests, and certifies radiation dampers. Intertek, ETL, Warnock Hersey, they also have products that are rated. They meet all the requirements of the building code. They have the same follow-up procedures as UL. They're just not as widely recognized because UL is the preeminent testing laboratory and the most recognized name in the industry, and UL has the directory of assemblies that we are penetrating. ETL tests and references those assemblies. ETL, Intertek, Warnock Hersey, they're all the same entity. They maintain their own directory of listings that reference the UL assemblies. Does that all make sense? So for some of you, you might see jobs that you specify a ceiling radiation damper, and the installer can look at those listings and look at those agencies and make a determination of what products are rated, what products are qualified. So keep going, digging into the building code. So again, we go through, and I put all this in here so you guys will have a copy of it, so I don't have to read everything verbatim, but it basically we tell you, the next part that we're going to go through is telling you where CRDs are required. All right, so it'll go through the different facets of construction. If you haven't ever read the International Building Code, it's riveting. Friday night, glass of Merlot, sit by the fireplace, just it reads itself practically. But you can go through in corridors. So are there any Canadians in the audience? No. Okay, so we won't get too deep in that. But building corridors has very special construction requirements. Depending on how we build the corridor will dictate the type of protection we need. So there could be smoke protection and there could be fire and smoke protection required. It all depends on how you construct that corridor, but there is a requirement, depending on how that's built, to have ceiling radiation dampers. And in this 708.4 describes that methodology of how you build that corridor for a rated lid using a wall turned sideways. We won't go too much into that. Again, it's all in here. We talk about through penetrations. Nothing in here says you can through penetrate and use a CRD, but from some what I call normative text, note 5 just says if you have a grill opening in a membrane, you have to protect it with the CRD. And then here is the actual listed membrane penetration. So number 1, you penetrate a membrane, you either need a shaft enclosure, so if we're going to multi-floor penetrate, or a listed ceiling radiation damper, and number 2 is for a ducted damper, and number 3 is for an open plenum return. All right, so there are your requirements for where the dampers are required. And now we got to talk about the rating and the installation, right? So all dampers, the International Building Code establishes the need that dampers must be installed per the manufacturer's installation instructions. There's no universal mounting system for a ceiling radiation damper. Every damper is unique to what was tested and listed. Now, we all share very similar mounting methods, but you have to look at the specific manufacturer of damper that you're installing. What manufacturer A has approved, you cannot assume manufacturer B has approved. Not a universal across. It's a little challenging from that aspect, but you have to understand what the ratings and listings of that damper are. As we go through this chapter, the building code, this section, one of the big things, one of the changes here you'll see in blue is this right here, dynamic systems only. CRDs labeled for use in dynamic systems shall be installed in HVAC systems designed to operate with the fans on. So in most commercial construction, when we say the fans are going to be on in a fire event, we think engineered smoke control system. That's intentional, that's designed, it's engineered. In multifamily residential construction, I'm going to put a unitary product, I'm going to throw it in, and I'm going to put it in a closet, and I'm going to heat or cool my entire apartment. Nothing in the code requires that unit under 2000 CFM to turn off in the event of a fire. There's no smoke detector in the return. There's no fire stat in the supply. You technically have created a dynamic situation. Your unit will continue to run in the event of a fire. That damper will have to overcome the forces of airflow, velocity, and pressure. So there are dampers that are tested to close under dynamic conditions. Now, this is a relatively new innovation within the industry in the last 10 years. Prior to the first dynamic damper getting certified, all floor ceiling assemblies were tested under static conditions. All dampers were tested under static conditions. That condition I just described to you existed, we still used static assemblies and static dampers. Today we're seeing more and more code officials, more and more engineers simply writing dynamic dampers are required. What you have to understand is the statement I made earlier. All that matters is the assembly number of what you are penetrating. You're a design engineer. You do a drawing for a 3-story wood truss building, and you say all dampers to be dynamic. If your architect did not specify the one of 2 assemblies in the UL directory that are actually dynamically tested with dynamic rated dampers, dynamic dampers cannot be installed because that has not been tested and approved for that. So what I'm getting at is there needs to be some coordination. If you are not an architecture engineering firm and there's a different architecture firm, and you're going to be doing the design on a multifamily property, you should look in the architectural drawings, talk to your architect, make sure you have those assembly ratings. For my installers, you can go through the architectural set. There could be a partitions plan. There could be a wall plan. You want to look at those, and there's going to be a number of that assembly referenced. Then you have to go back to that UL directory or ETL directory. And we have to look at those assemblies. There's lots of information in the assembly. And it's going to tell you again if it's dynamic or static rated. And per the code, I cannot use a static damper in a dynamic system. But if my my architect did not specify that dynamic system, what do? Well, this requires code approval, but all the building code cares is what that fan is doing. That fan is operating. So as the designer, design that fan to turn off. If you put a fire stat at the supply, say you have 165 degree fusible links, that's the closure temperature of our ceiling radiation damper, and you put a fire stat at 160 degrees in the supply, and you put a smoke detector in the return. If there's a fire, what's going to happen? Everything will shut down. So I no longer need dynamic dampers. I no longer have to coordinate with the architect to make sure they are specifying the dynamic assembly. That dynamic assembly for my designers has design limitations. There's a maximum size that is smaller than static assemblies. There's other design limitations as well that could cost more money than the solution to make the unit static. Does everybody understand that? Anybody have any questions on that? Okay. Now that is a code. That is not an exception. That is something you'll have to talk with your authority having jurisdiction to ensure that is an acceptable solution. We were seeing it kind of in the southeast areas. It works very well because it does comply with the building code. It changes it from a dynamic system to a static system. But again, all we really need to ensure is that floor ceiling assembly is specified, we know what that is, and the damper that we're selecting is appropriate for that floor ceiling assembly. So we talked about static versus dynamic. For those of you who don't know, I already explained it. Static is fans off, dynamic is fans on. We're going to have a minimum velocity and pressure rating for those dynamic dampers, 2,000 feet at 4 inches. And that's on our fire dampers and fire smoke dampers. So how do I know, as my designer, my installer, my sales folks, how do I know which damper is required? I've explained to you about UL 555C dampers that are approved for use for hinge door. We've talked about UL 263 specific rated assemblies, and we did talk about that confusing or statement, right? It's not a choose your own adventure. So we have dampers that are rated to UL 55C. We have dampers that are rated to UL 263. So those dampers that are rated to UL 55C, again, they're for use in assemblies that have previously tested and listed a hinged door type damper. And I'll explain what that is in a moment. And those are tested and listed to UL 555C. So those are those lay-in ceiling applications, maybe in a non-combustible truss system, and it's rated up to 3 hours. That's a very common application. Those dampers look like this. Now I have a specific floor ceiling assembly. Most likely it's a wood truss or wood joist assembly. There are some specific steel truss assemblies tested to UL 263. But the manufacturer damper is specifically called out in that listing. If I look at a UL 555C approved floor ceiling assembly, one that does not require a specific damper, it doesn't list damper manufacturers. It lists just the generic specification for what a hinged door damper is. So, you know, my damper company name, and I'm not going to mention a bunch of damper companies, but you're only going to see a few damper companies in those specific listings, and you won't see any in the hinged door damper. I have some examples here, but first, before I jump into them, the most important takeaway from today we talked about. Fire dampers are not ceiling dampers. We talked about ceiling fire dampers as a legacy name we're trying to get rid of. It commonly happens in that, again, that application. Let's say I have an air handling unit in the occupied space. I'm going to go through the membrane. I'm going to go through the truss space, and I'm going to drop a bunch of flex duct to registers throughout my apartment. That membrane penetration above the air handler requires a ceiling radiation damper. I got an 1800 CFM, that's a pretty decent size opening. Could be 18 by 18, could be 20 by 20, they get pretty big. Well, some ceiling damper manufacturers may not have a damper that big, or perhaps the contractor forgot to order one. A lot of times around the country, what we see is they go, well, I'll just take a fire damper and turn it on its side. It's got a fusible link, it's a UL listed product, that should do the job. Fire dampers limit the spread of flame. Everybody here knows what a fire damper is? It's a metal blade, metal curtain. There's no insulation. Nothing is limiting heat transfer. So now I'm going to put a curtain damper on top of a unit, and if there's ever a fire, nothing is preventing the spread of that radiant heat. It might have closed at the same temperature as the radiation damper. It's not doing the same job. That happens every day. I see it all the time. I talk to engineers. I talk to contractors. I've seen them installed in the field. It is not an approved installation for a fire damper. There's not a fire damper approved today for installation in a wood frame ceiling. If you think about it, what's going to hold that damper in the ceiling? Nothing much. So again, they're tested to 2 different standards, 2 different applications. They are not the same thing. So if you walk out of here today, the one thing I want you to walk out of is never substitute a fire damper for a ceiling damper or a ceiling damper for a fire damper. And then again, so we have 2, I call them 2 different types of CRDs, but 2 different applications. So we talk about the CRD and a wood truss CRD. All right, so the first CRD, again, those are the ones for use in lieu of the hinge door. And the second ones are for use in specific assemblies, most commonly your wood truss and wood joist type applications. And there's lots of differences between a fire damper and a ceiling radiation damper. The gauges of the metals, maybe the insulation properties of the blade, the actual design. And then between the 2 ceiling radiation dampers, there could be differences from the same manufacturer. So manufacturer A has a ceiling damper approved for that UL555C application in a drop ceiling. They also have a damper approved for a wood truss ceiling. They may look similar. They may be the same damper, but the model number and what was tested is very important. The literature has to line up from the perspective of the authority having jurisdiction. So while it's true that I take a UL555C rated damper and then I put it in a UL263 test and I get a specific listing for this assembly, I just can't take any UL555C damper and substitute it. That particular damper is required by the testing agency first to undergo UL555C, then to undergo UL263. That UL263, that's a unique test specific to that assembly. So you can't just take a UL555C damper and substitute it in any 263 rated assembly, unless that damper is specifically listed in the UL listing. Unfortunately, seems like a cop-out. If any of you ever call me with a question, I go, what's your design number? And they go, well, that damper is not listed in the design, you can't use it. And they go, but it's a damper. It does the same thing. So there is a case to be made for equivalency. You can talk to the building inspector and say, hey, the building materials to make this assembly are equal to the building materials of this assembly. The test standard to test this assembly is equal to the test standard to test this assembly. Everything is the same or equal with the exception of the damper manufacturer itself. The code authority has the ability to accept that damper. That happens every day on a daily basis. But it's the code authority's discretion to accept that damper. There is no requirement for them to do that. From the perspective of UL, there is no equivalency. From the perspective of UL, they look at the damper manufacturer difference as the claim for no equivalency. But from an educated engineer perspective, the damper's tested the same, does the same, the assembly is the same, the rating is the same. The authority having jurisdiction has the ability to approve that damper. Does that all make sense? So we look at those ceiling designs we talked about. So if I go into the UL directory, this is what a hinged door type damper would actually look like. And if I dig down into the specs, this is where it gives you that generic hinged door damper requirements. So wherever you see that, any manufacturer's UL555C radiation damper is acceptable. There is no manufacturer compatibility. I can have an air outlet made by one manufacturer and a damper made by another manufacturer, and that is acceptable as long as the dampers are rated appropriately and the air outlet is constructed to the appropriate requirements. Now, our specific assemblies will have a specific manufacturer damper model approved. So I go into the listing, and now there's specific models, specific manufacturers. Again, from the perspective of UL, if this was my system, this was what was being built, the only dampers that could be installed would be the dampers listed. As a contractor, engineer, manufacturer's rep, I can make that argument with the building inspector, but ultimately it's at their discretion to approve. So again, we have two types of designs when we talk about these very specific wood truss and wood joist designs. We'll have what we call an open design. So if you are in the UL directory and you're looking at a specific design and you see 5, 6, 7 competing damper manufacturers, the sponsor of that test, the sponsor is the person or company that said, UL, I want a certified product. And then they create a test plan and they go and they certify it. They control the materials that are used in that test. And subsequently, they're the owner of that listing. If a year later, another manufacturer says, hey, you've got my competitor listed, I would love to test my damper in your assembly. For most open assemblies, they go, sure, more the merrier, come on in, join the fun. Then you have what's called a proprietary assembly, and that's a damper industry term. Proprietary meaning the sponsor of the test was a damper manufacturer. We've done some R&D. We decide to go to market, and we only want our damper in the assembly. Since I'm the sponsor of the test, I control what manufacturers are allowed to be listed in my design. So if I establish a design number and my competitor says, hey, that's great, we want to get in on it, I go, no. You have to create your own number. And that's what happened in our industry, essentially. A bunch of manufacturers created their own assemblies that arguably are equal for all intents and purposes in rating, construction, test standard, with the exception of the difference being the damper and the damper manufacturer. It's just the system in the world that we live in. But again, from the perspective of UL, none of those assemblies are equal. From the perspective of a building inspector, that's his judgment to make. Okay? Because again, UL is just a testing laboratory. They're not an authority having jurisdiction. So there are other laboratories that can be approved. And I make this distinction because I have actually called UL and said, hey, I have this assembly. I'm a contractor. I want to use this damper. And they will say, that damper wasn't tested in that specific assembly, so it's not approved for use. And then I've made the same argument to the building inspector, and the building inspector has accepted the damper because the UL is not the building inspector. So that all makes sense? For some of you understand the dynamics of this situation in your market where you see these different dampers. I see the gentleman there shaking his head. So this is the biggest challenge about ceiling dampers. There's maybe 20 people here. You do it 20 different ways. 20 different ways it's inspected, 20 different ways it's designed. It's a very regionally specific product in the understanding, right? It's a product used to increase or speed up the construction of multifamily projects. Prefabricated wood trusses speed up your construction. So you can build buildings. If you drive down your highways of your cities and you see wood-framed apartment structures, where I am in Texas, we call that matchstick construction because it burns very quickly. But every one of those complexes, 3 stories high with a parking garage on the first floor, they're full of ceiling radiation dampers. How many of those are in your towns and cities? Right? Post-COVID, we kind of took a dip in our multifamily construction, and now we're coming back, and we're just going to keep increasing. So you will continue to see requirements for CRDs well into the future. All right, so for my installers and everybody else, what I look for on those contract drawings. You know, from the mechanical side, I worked for an installer. I worked for a manufacturer's rep. We don't ever look at architectural plans. We only look at mechanical plans. But unfortunately, the architect is the one who's specifying those assemblies. So we have to get comfortable looking at the architectural plans. So we need to look at the life safety plans, partition plans, assembly details, floor elevations, building section details. So here's a partitions plan. And it gives me the floor ceiling assembly, and it tells me it's a 1 hour floor ceiling assembly design, UL L521. I can now go to the UL directory, pull up that specific assembly, and it will tell me this is a 1 hour rated wood truss assembly that is a specific manufacturer's dampers listed. So again, like I said, building code requires the dampers, but we have to design the buildings properly. We have to design those floor ceiling assemblies, and we have to know what those assemblies are. And this is where they should be in the A set. Here's a building elevation detail, section detail. It'll tell me refer to this drawing. So we go find that. On my mechanical set, you guys know since you're doing it for the most part. But just to note, provide radiation dampers at each supply, return, and transfer grill that penetrates a rated ceiling assembly. That's not good enough. You need to show me where the dampers are and where they go, right? It only takes a little line with a flag on it, right? But putting a generic note, we are in the other side of the world where people quote and sell dampers. We're not fire protection engineers. We don't know where all the dampers go, right? And it's good for coordination to have those dampers shown on the plans. Just throwing a detail on the back of your drawing set doesn't tell me anything other than I might need a radiation damper. The first call you're going to get is, to my contractors bidding the job, submit an RFI to the engineer, to the architect, to determine what the floor ceiling assemblies are. And then there's another detail there. All right, so again, how do we select it? This is a little chart, comes from an AMCA white paper, Ceiling Dampers Explained. So all these assemblies are tested in the UL 263 fire test assembly. Let's say you get your assembly number from the architect, and we look it up in the directory, and it doesn't show me a hinge door damper, and it doesn't show me a specific manufacturer's damper, and it is a floor ceiling assembly. Well, guess what? No damper design or model is listed in that directory, which means no damper has ever been tested in that assembly. As a manufacturer, I cannot tell you, you can penetrate that with an HVAC duct and use my damper, and it will work, because I've never tested it. All right? We have this happen often, where the architect selects the wrong assemblies, everything goes to construction, and then we do that review, and we say, well, okay, this assembly, all those components are equal to all these components of an assembly that allows a damper, and all these tests and all these ratings are the same, so then you can go back to the authority having jurisdiction, and they can make it a discretional allowance to allow dampers to be used in that assembly. And then again, if we go and we see that, we look at that assembly, we see that hinge door damper that I showed you earlier, we know any UL 555C damper can go in it. It is not manufacturer specific. And then again, the last one, we look at the assembly, we see a list of damper manufacturers, that's who we're selecting. So for my installing contractors, for ceiling radiation dampers, low bid is not your best friend. The cheapest damper on the block, it might win you the job, but it might bankrupt your company. When a guy like me gets up on a ladder, sees all the dampers are wrong, and then tells the building inspector, every damper has to come out of this building. I did that once in Houston. Had a couple hundred units worth of finished sheetrocked in ceilings. All the sheetrock ripped out. Company went bankrupt. It was not a pretty thing to have to do. But they installed the wrong damper in the wrong assembly. They installed it improperly on top of that. So we want to make sure we understand the assembly requirements. Not to scare anybody, but that's not a good thing to have to rip out dampers and replace them. So we talked about the UL directory, talked about ETL, Intertech, Warnock Hersey. They have their own directory. You can also see Gypsum Association's specifications from the Fire Resistance Manual. So the GA Association is not a testing entity. They don't test anything. They reference already tested dampers and assemblies. So you can go into the design manual, you can find the GA number and see what UL assembly that references, and then you could select your damper from that assembly. We did touch on the dynamic CRDs. We'll go through it a little more. So again, static systems, the fans are off. Dynamic system, the fans are on. So dynamic rated dampers meet the building code for use in dynamic systems. And here's where we're looking at those ceiling assemblies in the UL directory. It now has a line that says ratings were developed under conditions employing air movement within a dynamic system. It's the first one of its kind, M557 is a floor ceiling assembly. There's an equivalent roof ceiling assembly. Every floor ceiling assembly has an equal roof ceiling assembly. And it's the only one of its nature in the UL directory. This is a proprietary design. You can go find it on the show floor. It's a great damper, but it is the only one of its nature, and this is the only design. So again, we go back to the fundamentals of, if my architect has not specified this assembly, and my engineer puts a note on his schedule that says, all air outlets to have CRDs and they are to be dynamic, you're going to get the wrong damper. You're going to get the incorrect model. We need to be a little more specific, and we need to understand that your notes on the mechanical plans do not supersede the fire and life safety requirements of that floor ceiling assembly. So again, until recently, all the CRDs commercially available were static rated. We now have a dynamic listed product, and we have to be aware of what those product requirements are when we use them. We can't just put those blanket notes, everything to be dynamic. Here's your test requirements out of the UL 555C test standard, table 10.1 for test airflow and pressure. Again, we're going to test up to 2,000 feet per minute, and for CRDs, it's 1 inch pressure. For fire dampers and fire smoke, it's 4 inches pressure. There's not that much pressure in a residential system. Even 1 inch is a lot of pressure, right? You guys designing pressures up to 1 inch in your system? Not often, right? But understand that that is a requirement, and it is also directional. So fire smoke dampers and fire dampers are not directional. There's no airflow label that says supply or return. My contractors can go in, they can install the damper this way, they can rotate it 180 degrees, install it that way. That's fine. CRDs that are dynamically rated, that is not the case. They are rated for upflow or downflow. Complexity. So for my designers, again, if my complexity of turning my system static or ensuring contractors read the model numbers of what's supply and what's return and where they go on the plans that were not detailed because my engineer only wrote a note, put a damper anywhere they're required, that's going to be difficult to put those dampers in the right place, right? That's why we can't put notes on a drawing. That's why we have to show where dampers go. And so again, it's a proprietary listing. Only the specified manufacturers that are in that listing can be used in that dynamic listing. There is nothing else equivalent to it in the industry. I can't make any case to any building inspector other than creating a static system instead of a dynamic system. That is my only out in this case. The other thing that we need to be aware of, there's not just dampers listed in these listings. The manufacturer and model of the sheetrock being used, the gypsum board being used, is detailed. And from the perspective of UL, a substitution would not be allowed. So if I have a type C gypsum approved, and I can no longer get type C gypsum because it's been obsoleted, I cannot substitute that if there is no other gypsum tested and listed. Today, the only gypsum approved in the dynamic ceiling assembly is type C from USG. Type C from USG was obsoleted 3 years ago. Unless you are sitting on a warehouse of that and you need to build a very large building, you will not have enough sheetrock to build that building. And you cannot substitute it without the approval of the AHJ. And there's nothing for me to make any claims because it's the first and only one of its kind. So again, it's easier to change your system from dynamic to static than it is to build a dynamic system. That was it. That was quick. That was good. There should be a lot of questions, and there's not, I understand. But I do appreciate every one of you taking your time to come here. This seems like a very easy thing, a damper in residential multifamily. And it's one of the most challenging questions we get on a daily basis on this industry. And it's very important that we get it right. It's fire and life safety. These are multifamily, low-rise, mid-rise, and high-rise apartments. Lots of people, right? So it's not a matter of comfort. Right? If I missize my air outlet, maybe it's drafty, maybe it's noisy. If I pick the wrong damper, somebody could die. We don't want that. Buildings can get destroyed. So I'll leave you with that note. And if anybody has any questions, please let me know. You got, you first. You had your hand up first.
What do you about linear dampers or linear registers?
So there is a category in UL, BZZU, for air diffusers that are tested as an assembly. So there are plenum slot diffusers that go into a lay-in grid that are tested as an assembly with an integral ceiling radiation damper. There are we call them fire-rated package diffusers. Go to any of the major GRD manufacturers and they'll have a catalog of them. There's no such thing as a ceiling radiation damper that can be added to a linear plenum to create a fire-rated linear damper. It will have to be tested and listed as an assembly. Typically, those are lay-in applications only. All right, so your fire-rated packages, we all know what I mean when I say a fire-rated package? No? Good, I'll tell you. It's a diffuser with a thermal blanket and a ceiling radiation damper as an approved factory assembled assembly from a single manufacturer. It's a marketing gimmick. It's not a code requirement. There are very few manufacturers that make all those components. So the industry has to buy a diffuser from vendor A, a CRD from vendor B, and maybe they get a blanket from the same vendor, maybe they get it from somebody else. Or, for ease of specification and contractor installation, they can just buy a fire-rated package. And it's got all those components, and we know they're code approved because it's a tested, listed assembly. That make sense? All right, excellent. Next question.
I think you mentioned at the beginning that it requires a CRD.
Wait, what was the first part of that? Yeah.
I think you had mentioned that it requires a CRD right here.
Any penetration of the membrane.
I think on the graph where you had an outlook of the fire for the CRD, I think that will show the fire damper. I've seen that on plans.
Yeah, and we said that is not the correct application for a fire damper. That is not an approved installation. If we take the installation manual of a fire damper, there's no way to install that. There's nothing telling me how to install that in a wood truss floor or a wood truss ceiling or a wood joist ceiling. There's no method of attachment that's been UL tested or approved. Maybe you could if you tested it, listed it, and got it approved. But what I always go and say is, we can have a very intelligent conversation of how it makes sense, and the bottom line is, if it's not tested, listed, and approved, nope. Which drawing? This one here? That's not my drawing. I got that from Dodge. Good catch. From my engineers. Yeah, so that's a symbol for a fire damper, but that's an engineer who doesn't recognize the difference between a ceiling radiation damper and a fire damper and just uses the same symbol.
That's wrong.
If I went to the symbol legend and that F said equals fire damper, yes, that's wrong. If I went to the symbol legend and that F said equals ceiling damper, it's correct. So technically it's right and wrong. It's Schrodinger's cat of designation there. So, but yes, you're correct. That you would not ever, unless that is a rated shaft. If that's a rated shaft, then that could be a fire damper. That number 3 just says an air duct from a furnace up between joists, so that's not a rated shaft. So that would not be a fire damper application.
So ceiling radiation damper can go within a duct, right? It's not just that amount.
Ceiling radiation damper would go at the membrane penetration of the ceiling.
It's a duct or if it's an outlet.
Correct, yeah, it doesn't matter, yeah. Could be an open plenum return to the ceiling. Ceiling damper would still be required, correct. Of course.
Question on the, it used to be you had to go to UL, what we had to pay for to get assemblies. Is that all available online now?
Yeah, you go to ul.com, look for what's called the Product IQ. You need a login, it's free, company or personal, and then you could go, let's see if this will work. No, it's going to make me hold it. You go to their website, put UL Product IQ, log in for it. Within an hour, you'll have a registration, and you could search anything you want by manufacturer, by ceiling assembly design, by category code, if you knew what the UL category codes were. All the information in those directories are now digital. I usually make a joke and I have a picture. I don't have it in this presentation. I did in my last one. I have the picture of the orange books and I have a picture of the website. And I say, for all my younger folks, those things on the left are called books. We all used to use them and used to have them in our offices, but nobody uses them anymore. So, yes, you can access that online. All right, excellent. Great questions. Any more? Oh,
So we've discussed a lot of like what these are, where and when we use them, how we install them, how many terminals we need. How do they actually work? How do they prevent that heat from getting through?
So, a very great question, and it's going to lead me to edit my presentation to do a better job of explaining that. So when the blades close, the blades are held open by a fusible link. A fusible link is a UL listed product. It's a bimetallic disc. It's two pieces of metal held together with a solder. That solder melts at the specified temperature of that link. So let's say 165 degrees. Once those blades close, they've now created a thermal barrier. Some of those blades may have an insulating material on top of it. Maybe it's a thermal blanket. Maybe it's actually a piece of fire-rated sheetrock for some manufacturers. Depending on the size of the damper dictates how much insulation you need. Typically smaller dampers need that, larger dampers don't. And that barrier is now created. That damper in the closed position has made up that continuity of the barrier. So it's just creating a radiant barrier. That's all it is.
All right, that makes sense.
Makes sense. Excellent. Good. Great question. Great question. Yes, sir.
Is it true that 165 degrees is the only temperature?
212. You can do a 212 link as well. Most manufacturers default to a 165 link for their CRDs. Some actually default to a 212. So if you think about where CRDs typically are, attics. Attics get really hot. So Wood Truss Multifamily Construction is a product of the South. That's where it came from, right? The guys in we'll call it the Southern Belt, that's where we see it a lot, and it's migrated all over the country now. But 20, 25, 30 years ago, it was huge there. Attics get really, really hot, and they can see temperatures up to, I don't know, I don't work in attics, fortunately. But, so some manufacturers have decided to reduce the occurrence of nuisance trips, because some of those attics in Arizona with unventilated, that could get pretty hot. So you can see 212. The code just requires minimum 165 link. It'll say 50 degrees above ambient is what the closure temperature is required, and that usually results in a 165 link. Excellent. Now for fire dampers, you've got a 165 link, a 212 link, and a 286 link. You don't have that for CRDs. Dane? No? Good. Thank you. Yes, sir.
There's part of the code that allows, and I'm not sure the numbers, but you can mention it. If you have a hole of a certain size, you're not required to put a damper in. It's like, I know from dryers, 4-inch round, you don't need it.
4-inch round, there is a provision in section 7. And
It's such a size hole per so many square foot of surface.
exactly. Yeah, you can't exceed we call it the aggregate opening. You can only have so much opening and so much square foot of 4 inches.
Is that just not really a practical issue for condition there?
It's not really practical for CRDs. We don't see a lot of CRDs in ducts below 4 inches. We don't see any 3-inch ducts. You can't move a lot of air through a 4-inch duct. So we don't see a lot of that in the design itself. So there are other ways to lessen the need for use of CRDs, but that's not one that's commonly used as an exception. It might be used in a range penetration. That's one where typically we see that because the range hood penetrations are 4 inches.
Either 4 by 10 or 3 by 10 typically.
I've seen just straight round penetrations that are 4-inch round before. It all depends. So a lot of the challenges you guys are going to see is the technology of a radiation damper. What are we 30 years old now? More than that, 35? But the intent was for low-cost, quick multifamily construction. Cheap building materials, get them built quick, get occupants in, make money. Now we're doing high efficiency VRF, mixed use, multi-use, commercial on one floor, residential on the next, and a movie theater on the top floor, And we're trying to do things that are outside the scope of what these assemblies were tested for and what the dampers were intended to do. So that didn't answer your question at all. I just wanted to say that out loud. For my designers, you're really smart. You're way ahead of us when you're designing your systems. And when you think you have this great idea of how to do all these things, you're limited by the assemblies that you're using. All right, so if we're going to start using fan coils and we need outside air intakes, those have to be protected if they're penetrating the membrane. All right, same thing with, again, those other penetrations. So, sure.
In reference to that exception that he was talking about,
Yeah.
At least in the Michigan Mechanical Code, we have that for under 100 square inches for those penetrations.
Okay.
And then when the duct is heavier than 24.
Everything, yeah, exactly. Yeah, there are, like you said, there are conditions outside of just the diameter of the penetration that you have to conform to. Yes, sir.
Is there a height restriction on the damper being close to your penetration?
That's a really good question. Most people don't think about that. So what the question that was asked, if you didn't hear, so I have my rated membrane, I have my penetration. Is there a restriction or a limitation on how high that damper can be mounted above that penetration? And that answer is yes. It will be detailed in your installation manual for that specific damper. It's not universal across the industry. And it depends on the damper model and the damper type. And why that's important is because, again, technology's outpaced dampers. The original dampers in a wood truss assembly were cheap residential Home Depot $25 sliding gate, the cheap stuff you can buy. Not all the cool engineered stuff we have downstairs. Those are about an inch, less than an inch deep. They're sometimes just flat stamped grills. So you have a lot of clearance between the opening and the damper blades. But now we have engineers that want to do double deflection supply grills with opposed blade dampers. Does anybody want to guess how deep that assembly could be? 4 1/4 inches, great guess. Most commercial grills, single deflection, right, 3/4 of an inch, add an opposed blade damper, you've added a couple more inches to it. And now it doesn't fit in those requirements. So what typically happens, contractor just installs the damper higher. A lot of building inspectors around the country are not measuring that distance. They're not looking at that distance, but for the ones that do, that's something that's going to require you to rip that entire damper out of the ceiling and reinstall it. And reselect your air outlets and how you're balancing your system. So again, I have a little tagline I like to say, call before you install. If you're doing a multifamily design, it's not your first love, it's not something you're comfortable with, and CRDs are required, call your damper representatives, call an AMCA member company, talk to somebody, because we want to save lives. We want people to live safely and not have to worry about, is my apartment built properly? Where's my nearest fire escape? So, more questions? Anybody else? No? All right, excellent. Well, again, thank you so much for becoming the most educated in the entire show on ceiling radiation dampers. You guys are great. Thank you so much. All right.